So lesson 7, section 8, just shows us some really cool ways to use matrices, and I love to teach this because it's just so different than anything we've learned. So we're working with applications of matrices. It says, how do you use matrices to solve systems of equations? Hey, we know that. Find areas of triangles, we're going to work on that. And write coded messages, we probably won't do that. All right, so if we look at the area of a triangle, we know the area is equal to plus or minus 1/2, and they have this weird thing here. So it says x sub 1, y sub 1, and 1, x sub 2, y sub 2, and 1, x sub 3, y sub 3, and 1. So notice that it does take 3 points to make a triangle. So that's where they're getting x sub 1, y sub 1, x sub 2, y sub 2, and x sub 3, y sub 3. So let's start out by looking at the area of a triangle whose vertices are 0, 0, 4, 1, and 2, 5. Excuse me. So the first thing we're going to do, I'm going to blow it up so you guys can see, is we're going to set these up as matrices the way they said. So the first triangle was 0, 0. Remember, they always put a 1. The next triangle was 4, 1. They always put a 1 in that third column. And 2, 5. So we're going to find the area of the triangle by evaluating the determinant by expanding along row 1. So the reason we say plus or minus 1/2, plus or minus 1/2, is because we know that we're never going to have a negative distance for the area. So let's dive in here. We're just going to use the first row here. So we're just going to use this row right here. And we're going to go ahead and just like our minors and cofactors, we are going to assign a positive minus a positive. So remember this was plus minus plus. I probably should do that in orange. And the first thing we're going to do is take the first number, 0, and multiply it by the determinant, 1, 1, 5, 1. And I'll deal with that later. And then we have minus, so remember that goes there. And then we have minus, and I'm going to take the second, so we're going to cancel these out. And I'm going to take that 4 and multiply it by the determinant. So I'm just going to write it out. 0, 1, 5, 1. Hopefully it will let me erase and not erase too much. Yes, that is wonderful. And then we're going to go ahead and take this, cancel that out, and we're going to take the 2 and multiply it by the determinant, 0, 1, 1, 1. So this is what we're working with right here. So let's do the work. Well, we know anything times 0, it doesn't matter what the determinant is, but I'll go ahead and write it out. It's a positive 0, and I know that when I take 1 minus 5, I get a negative 4. Well, I know this is going to end up being 0. Minus 4 times 0 times negative 5 is negative 5, plus 2, 0 minus 1 is a negative 1. So I know that this is going to be plus 20 and minus 2, which gives me 18. Now, because of what I said earlier, we do have to take that half of 18, and because it is a positive 18, we're going to keep it positive because the area is always positive, and we know that the area of this triangle is 9 units. Now, what happens if the area of a triangle is 0? We are going to call those collinear points. So we can use that same test for the area of a triangle, and if it is equal to 0, we know that those points are collinear. So we want to make sure we know what to call it when that happens. So that's what we would call it, collinear points, and we will try one of those. So let's practice again. I pretty much told you the answer to this because I told you it's going to be collinear. But we're going to go ahead and set it up. So remember, the first thing I'm going to do is set up my matrix, -2, -2, and the 1s go all the way down the third column. 1, 1 will be my next point, and 7, 5 will be my next point. So we're going to set it up as positive, negative, positive, and don't forget we're going to take that, the positive of 1/2 of whatever this becomes. So when I find this point, I'm going to take that -2 and multiply 1 minus 5. 1 minus 5 is -4. And then I go here. I'm just going across the row this time. I think last time I went down. You could do either way. And this cancels out. And I have 1 minus 7. So I'm going to take the -2. And 1 minus 7 is -6. Next row, I'll do in pink. Cancel, cancel. I'm going to take this 1, and I have 5 minus 7, which is -2. So I end up with 8. Here I end up with a -12 and a -2. Oh, this one was just asking me if it's collinear. So I know that this is a -6. And again, if I had to take the opposite, remember the actual area would be 3. This one is not collinear. So that one was just asking us whether or not it was collinear. This one was not. What about example 2 above? Are these collinear? Yay or nay? Let's set it up. I have 3, -1, 1, 0, -3, 1, and 9, 3, 1. I have my plus, minus, plus. And I'm going to go ahead and start here. I'll start with pink. Cancel, cancel. So I have 3 times -3 minus 3 is -6. Going purple, I'm going to go straight across again. Cross out here and here. So I have -1 times 0 minus 9. That would be a -9. 0 minus 9 is -9. And then I'm going to go here, cross out, and I have 1 times 0 minus a -27, which is +27. Let's see what we end up getting here. 3 times -6 is -18. Looks like these cancel out to be -9 plus 27. Hey, guess what these equal? So this one is collinear. Great job.